Okay, yesterday you watched a video on graphing the cosine function. Today is the sine function. Picture the same unwrapping of your unit circle and how as you unwrap that, the function continues to follow the same path, okay? So with cosine, we were graphing what we call the 5 main points, and those are your quadrantal angles. So at 0, pi halves, pi, 3 pi halves, and then 2 pi, right? And when you look at your ordered pairs there, you have 1, 0, you have 0, 1, you have negative 1, 0, you have 0, negative 1, and then 1, 0 again. Now with cosine, you graphed your x values. With sine, we're going to be looking at the y values, right? So 0, 1, 0, negative 1. And just like with cosine, we can make a table of values before we actually start sketching these. So your x value is like your theta, your angle. So you have 0, pi halves, pi, 3 pi halves, and we end with 2 pi. And now the function we're graphing is sine of theta. So what is the sine of that angle? Again, that's the y value at your ordered pair. So here it's 0, here it's 1, here it's 0, here it's negative 1, and then we end at 0. So when we go to put this on our graph, this is like our theta axes. It's your x-axis, but your horizontal axis is now in terms of theta because that's our input. Your output is your, we can still call it y because technically what we're graphing is y equals sine of theta, okay? So your x value or your theta value is 0, pi halves, pi, 3 pi halves, and then 2 pi. So these are considered to be your 5 main points. At 0, the output is 0. At pi halves, the y value is 1. At pi, your y value is 0. At 3 pi halves, your y value is negative 1. And at 2 pi, you end up at 0. Now, yes, we could graph the y value at pi 6, the y value at pi fourths, the y value at pi thirds, right? But if we did, what you would see is it would kind of follow that little curve right there, okay? So even though we're not graphing pi sixths, pi fourths, pi thirds on here, all those points are technically there, okay? But we're just going to use those 5 main points from your quadrantal angle to give us the max height, the min, the lowest point, the midline, all that, because those ones in between, they're going to change as you connect those 5 main points anyways, okay? And then, so notice here, all your sine values in your first quadrant are positive. All of these points along this arc right here, those follow all the heights here. So that's like your first quadrant y values. Then your second quadrant y values, notice they're all still positive. They're starting at 1 and going to 0. And that's where this curve comes in. Now notice once you get into the third quadrant, the values get your y values. Now remember, this is your y values. They get negative. So what's going to happen here? Those outputs are going negative. Okay, because technically that's what you're graphing. And then in your fourth quadrant, your y values are still negative. So there, our y values are still negative. Okay, I'll go over this one in yellow just so you can see. Quadrant 1 is in red. Quadrant 2 is, all those points are graphed in yellow. Quadrant 3 in blue. Quadrant 4 in green. And that's what those represent, okay? So just like with cosine, we can do vertical stretches, vertical shrinks, vertical reflections, vertical shifts. We can do horizontal stretches, horizontal shrinks, horizontal shifts. Everything horizontal will happen next year in pre-calculus. But let's take a look at graphing with a change in your amplitudes, like a vertical stretch or a vertical shift. And remember, this is your parent graph right here, okay? So notice that to get through one sine curve, it's 2 pi, just like with cosine, so we call that the period. equals 2 pi radians. And each section is broken up into pi half radians because that's what each quadrant is broken up into. Okay? Yeah, so let's go ahead and take a look at some changes in our graphs. Okay, so let's say we want to make a change in our amplitude. So let's just do y equals 3 sine theta, okay? So just like with when we did transformations in the beginning of the year, if this is our parent function, 0, pi halves, pi, 3 pi halves, 2 pi, sine starts at 0, 1, 0, negative 1, 0. When you had a value outside the function, remember outside affected your output. So what do we do with our output? We times them all by 3. So 0 times 3 is still 0. 1 times 3 is 3. 0 times 3 is still 0. Negative 1 times 3 is negative 3. 0 times 3 is still 0. Okay? So what this is going to change is the high and low points, okay? We didn't change anything on the horizontal axes. It's still, we didn't do anything to our input because notice nothing is inside of the sine function. So if it was inside, like if it was in front of that theta, then we would have to change those x values. And again, that's something that'll come up next year. So now, instead of being our highest point at 1, our highest point is at 3, and our lowest point is at negative 3. So since we just multiplied each value, our outputs by 3, we have our new graph. Okay, how does this look different compared to our parent function, our parent graph? Your parent graph would look like this. I'll do it in dotted, okay, just so you can see the difference. So you can see that vertical stretch that has happened, okay? Next, let's go ahead and look at one where we have a vertical shift. Okay, so what we have here is y equals 2 sine theta minus 1. Again, inputs theta. Our parent graph is sine theta, right? So now, let's think about back in the beginning of the year. We have a vertical stretch of 2 and a vertical shift of down 1. So what are we going to do with our output first? Our output is sine theta. We're going to multiply it by 2. So first step, let's multiply all these by 2. And then what we're going to do is, so that's the multiplication of 2. Then we're going to subtract 1. So 0 minus 1, 2 minus 1, 0 minus 1, negative 2 minus 1, 0 minus 1. And so what we should find when we go to graph this, we still haven't changed our input, right? Our thetas. All we've changed is we've changed our amplitude and we've changed our midline. So notice your highest output is at 1, your lowest is at negative 3, okay? So this down 1 has changed our midline. So we have a midline instead of, this is our middle of our graph, instead of y equals 0, it's y equals negative 1. We always show that with a dotted line going through negative 1 because you want to make sure that's the middle of your sine curve, okay? So your highest point should be 2 up from that, and our lowest point should be 2 down from that. And that comes from your amplitude, okay? So this right here. And amplitude is always positive. Even if it had a negative in front, that would show a reflection, but it still would say an amplitude of 2. What an amplitude means is if this is your midline, no matter where it is, your highest point is 2 up, your lowest point is 2 down from that, okay? So now let's look at it. At 0, your output's negative 1. At pi halves, our output is 1. At pi, your output is negative 1. At 3 pi halves, it's negative 3. And then you end at negative 1. So notice how your maximum value is 1. That's 2 up from the midline. Your minimum value is negative 3, and that's 2 down from the midline. And the reason it's 2 is because of the amplitude. If we change that number to be a 4 in front, then it would be up here and down here. Okay? Again, your parent graph, I'll just show it to you in a dotted line. Would look like that. So you can see how the amplitude changed and there was a shift down 1.